afternoon, everyone. Welcome back, Super Educators. I'm Yogendra Singh, your host for this session of Mathematics Summit 4.0. We have already had two incredible sessions today, exploring how mathematics can be taught in more engaging and meaningful ways. And now it's time for our third session of the day, one that focuses on building a mindset in students that goes beyond formulas and rote learning towards creativity, confidence, and problem solving. Our session is titled Nurturing Math Mindsets for Creative Problem Solving, and it promises to be both inspiring and practical. We are honored to be joined by Dr. Garima Arora, founder of Uncover Math Genius. Dr. Arora is dedicated to transforming how children learn mathematics by building critical thinking, creativity, and confidence. She holds a Ph.D., is a published author, and serves as a lecturer at the University of Delhi. With over 15 years of expertise in math education and curriculum design, she has authored more than 10 books and has positively impacted over 5,000 students and 3,000 teachers through inquiry driven innovative methods. Her mission is clear to move learners beyond rote memorization towards deep conceptual understanding and creative problem solving skills that are essential in today's AI driven world. Participants, just a quick reminder, tomorrow, after the sessions, get ready for the much awaited quiz starting from 5 p.m. onwards. Stand a chance to win Amazon vouchers worth up to rupees 48,000. Now, some housekeeping rules. Participants will be muted throughout the entire session. Please ensure you have a pen and paper to note important information. The chat box will only be enabled during the Q&A round and as required by the speaker. To receive your e-certificate, please fill out the feedback form that will be sent to your registered email ID by Monday. Don't forget to participate in the quiz tomorrow after the session. So let's not wait any longer. Please join me in welcoming the inspiring Dr. Garima Arora. Over to you, ma'am.
Thank you so much for such kind words. Thank you so much. I'm really excited for the session. So I think without wasting much time, let's dive into it. I'm going to share my PPT with you, and the questions are most welcome towards the end of the session. I hope my PPT is visible to everyone, is it?
Yeah, ma'am, it's visible.
Okay, thank you so much. Okay, so a very good afternoon, everyone. It's truly a pleasure to be here with passionate educators like you. Now, let me start with a simple question. Which subject do children fear the most in schools? I'm sure you must all be thinking it's math, right? And isn't there at least one child every single day who says, I hate maths and it just does not make sense to me? But here's the truth. Math isn't the problem. Math is, in fact, one of the most natural, beautiful, and intuitive subject a child can learn. The real issue is the way it is taught. For too long, we've taught children to memorize steps and formulas and get the answer, right answer as fast as possible. But ask them why they did what they did, and silence fills up the room. Creative problem solving in math begins with mindset. And when I'm talking about mindset, I'm not talking about the children's mindset. I'm talking about our mindset, the teachers. Actually, in today's AI era, teacher word itself is wrong. We need to shift our role from being teachers to that of being facilitators. And the creative problem solving begins when we ourselves move beyond rote to root, from formulas to patterns, and from that's correct or that's the wrong way to asking why. It begins when we stop focusing on worksheets and start helping children tackle real, meaningful problems. In this session, we're going to challenge a few long held beliefs. We'll explore, simple shifts we can make in our classrooms, shifts that don't need fancy tools, but a different lens. Because the real goal is not just to finish the syllabus, it's to nurture thinkers, explorers, reasoners. It's time to move from procedural math to powerful math. Now, you might think, yes, this is ideal, but is it practical? So, let me tell you that at one time in the history, it was fancy. It was an aspiration to teach math this way. But with the onset of artificial general intelligence, chat gpt and other apps, it is no more an option but an immediate need for all of us. If you think this, AI shift is a buzzword or something that will, affect others and not you, let me give you a reality check. I'm sure everybody knows about Khan Academy. It recently launched an AI based tutor named Khanmigo. It doesn't just give you answers, it explains concepts, it gives step by step feedback, and even adapts to a child's pace and confidence. It's like, having a 7 cross 24 personal math coach built on AI. And if you think children will not use any of these tools, then you're wrong. They adapt faster and, much better than any of us. In no time, they'll latch onto this. And when they do, they'll question the relevance of the classroom itself. In fact, it's already happening. You look at this ASER 2022 report. More and more children are going to tuitions instead of learning in school. And now with AI tools, they may not even need tuitions because help is available instantly, anytime and anywhere. But this isn't a threat, it's a wake up call for all of us. Educators who don't evolve will be replaced by AI, but those who understand how to teach with depth, who know that teaching math is about connection, curiosity, critical thinking, they will not just survive, they'll thrive. That's why today's session is, that's what it is all about. Because again, the real goal is not to finish the syllabus, it's to nurture thinkers, reasoners, explorers. And it is the right time to move from procedural math to powerful math. But before we dive into how we do that, let me take a moment to introduce myself. He's already done it, and share why I'm so deeply invested in this mission. I'm Dr. Garima, a math educator, mentor, and someone who spent over 15 years exploring what really makes children understand math and not just pass exams. Over the years, I've had the privilege of working with over 5,000 students from KG all the way up to college, including my own two kids. And trust me, your own kids are always your toughest classrooms. But in the last few years, my real passion has shifted. Today, I work with teachers, mentors, educators like you. Through Uncover Math Genius, I've supported over 3,000 teachers to move beyond formulas and drills to build classrooms full of curiosity, reasoning, and joy. Because when a teacher shifts mindset, a whole generation of learners shift with them. So let's get started with a poll. Okay, so I would want to ask you, what do children say most often in your class during math period? Let's make it more interactive. Let me just see if I can start the poll, or you can write it in the chat box. I mean, that would be easy for me because I can't. Uh, just. So I need somebody who can actually start the poll if you can. Any of the team members, if you can start the poll. Okay. You can just write it in the chat box. What do children say most often in your class during math period? I would want to see people writing in the chat box. Let's get more interactive. Where we are going to use the concept in real life. That's true. That's stable, talking with others. Uh, can you teach one more time? I can't understand, sir. Very true. Boring. Fear of recitation of tables. More real life examples. Maths nahi aata. That's so true. Won't listen at all. Do you notice something? We hear a lot of this. I don't get it. I don't know the formula. I don't know maths. Will this actually come in the examination? It's very confusing. But how many children are saying, can I try it, a different way? Or even just, why does this work? That silence speaks volume. It tells us that our classrooms are full of answers, but not enough questions, full of compliance, but not enough curiosity. And that's exactly what we are here to change today. Now, let me show you where the real problem starts. Not in high school, not in algebra, but in kindergarten itself. When we ask children questions like this, what is 7 plus 3? Let's try it right now. Drop your answers in the chat box. Go ahead. What is 7 plus 3? 10. 10, 10, 10, 10, 10. Yes, 10. I'm getting a lot of 10s. Right. So I can see most of you typed 10, right? Because we've all been taught 7 plus 3 is 10. But let me ask you something strange now. In how many real life situations is 7 plus 3 actually equal to 10? Just one. When you're adding plain numbers with no context. But now watch what happens when we add context. 7 apples plus 3 oranges. It's not 10 apples or 10 oranges, right? 7 meters plus 3 centimeters is not 10 meters. 7 months plus 3 days. Definitely neither 10 months nor 10 days. 7 dozen plus 3 bananas. It's not even close. So 7 plus 3 is only 10 in the absence of meaning. But real life is full of meaning. And our math teaching often removes it. Now, the key point to drive home is when we teach 7 plus 3 equal to 10 blindly, we train children to think math is about numbers, not about relationships, quantities, or units. And that's why by the time they reach word problems or algebra, they're lost. Now, let me show you the same problem from a different lens, this time through fractions. Because in my experience, fractions are the most critical turning point in math education. This is where many children, even the confident ones, they start to disconnect. Not because they're lazy, not because they're not trying hard enough, but because fractions mark the moment math stops feeling real to them. This is where numbers become less intuitive, less visible. They can't see it. And if you don't teach this right, we lose them. Now tell me, what is 1/3 minus 1/4? Sounds easy, right? Yes, I can see already people, dropping their comments in the chat box. It's 1/12. But in my 15 plus years of teaching, I've seen hundreds of children, even in middle school, struggle with this. Now let's reflect, all of us. What do we usually tell them to do? Take LCM of 3 and 4, convert both to like fractions, and then subtract, right? They follow the steps like a script. But then what happens next? The moment you ask them, what is 3/5 plus 1/4, they confidently write it as 4/9. And what do? We tell them to practice more, do more sums, try harder. Because somewhere we've all been conditioned to believe that math equals more practice. But let me say this loud and clear. This is not a practice problem. This is a concept problem. Your student is not careless. Your student is not lazy. Your student is not underprepared. Your student did not understand the concept, plain and simple. You're asking a 9-year-old to manipulate abstract numbers without ever showing them what 1/3 and 1/4 actually look like. At that age, they're not wired to think purely numerically. They need to see the math, touch it, break it, rebuild it. And this is where our role as teachers has to evolve. Because Google can give the answer, Chat GPT can give the steps, but only you can see what the child isn't seeing. Only you can notice the exact gap in understanding and present the concept in a way that clicks. That's the future of teaching. Let me ask you something else. What is doce menos diez? Type your answers in the chat, everyone. What is doce menos diez? I want to see people writing, interacting. Anyone? Don't know? Dos. Okay, somebody wrote it as dos. So because it's okay, because I know that most of the people would not know about it, because unless you know Spanish, this feels like a trick to you, but it's not. So doce is 12, menos is minus, and diez is 10. The answer is those, as what she's written correctly. I can't see the name, sorry. It's 2. But until I told you that, you had no clue about it. And even now, some of you may forget it 5 minutes later. Why? Because this is just like 1/3 minus 1/4 for our students. For most children, math feels like a foreign language. They're told to take the LCM, find equivalent fractions, subtract without knowing what any of those things mean. So they memorize steps like, if the denominator is different, take the LCM, cross multiply, apply butterfly method, and so on and so forth. But they don't know why. And here's the thing. What they see and understand, they remember. What they memorize without meaning, they forget. Some sooner, some later, but they forget. Let me now show you how children really need to learn this, because when children see it and understand it, they rarely forget. They might even build on it, create their own shortcuts, make connection. And that's the real learning I'm talking about. But what they only memorize without meaning, they will forget. So the next time you teach something like one third, what is one third minus one fourth? Don't just give them rules. Help them see it. Let them feel it. Now, let me show you what I mean to say. Now, if visually, you all can see the screen. If visually this is 1, then one third is 3 equal parts of the same 1, 3 equal parts, and one of it is one third. One of it is one third. This is one third, right? And similarly, of the same one, of the same initial strip, this is one fourth. One fourth is 4 equal parts, and one of it is one fourth. Now, what is one third minus one fourth? The extra part, just keep your one fourth on the one third. The extra part that you have is the difference between one third and one fourth. So this is the extra part that I can see. That is the difference between one third and one fourth. Now, the crucial concept is, if this is one, if this is your one, the one you started with, then what is this part? What is this part? Right? And if you just keep on it, when you do it yourself using the strip, you will see that exactly 12 of these pieces will fit the original length. Now, just pause for a moment and think. Was that difficult to explain? Did it take any fancy tools or expensive resources? It was just a piece of paper. All it took was a shift in perspective from how do I teach them to get the answer to how do I help them truly understand what they're doing. Because our job is not to help children finish the worksheet faster. Our job is to help them build a foundation that lasts. When they see it, when they feel it, when they make sense of it, they own it. And that's how we nurture math mindsets, create problem solvers, and not just calculators. Now, this is a collection of the top 10 skills on the rise as determined by the World Economic Forum, which studies the economic or the financial growth and development of the world. This study is backed by several big organizations like Google, Microsoft, Forbes, etc. Out of these 10, 5 of them, which are creative thinking, analytical thinking, technological literacy, system thinking, AI, and big data, they rest on a strong foundation in math. And if you nurture, children's math mindset correctly, you'll definitely be able to sustain your students' curiosity and motivation in learning. I'm sure each one of us would want our students to be the part of this growth. So the question now is, what kind of math will prepare children for that future? What kind of math do we talk about when we say we need to nurture math mindsets? Certainly not the kind we've been handing, down for generations. Let's look at the difference. Math today, as most children experience it, is full of formulae, full of memorization, which looks so different from the real world math. We teach long division method to children. How many times do we use it in our everyday life? I'm not saying that don't teach long division method, but what I'm saying is go beyond into the realm of real math. Real math is a language, not a bunch of disconnected tricks. It is conceptual, it is contextual. Its purpose is to communicate ideas, explain patterns, and solve real world problems. Math today is often reduced to getting the right answer and following the steps. That's it. And if a student misses even one step, marks get cut, confidence drops, and curiosity dies. But real math is the opposite. It's about inquiry. It's about, exploring ideas, asking questions, and building frameworks to check if your ideas are possible, not just whether they are correct. And that's how math works in the real world. It begins with wonder, not a worksheet. Today's math, it is about how to follow steps to get to the correct answer. But real math is all about knowing the why behind the concept. Why we need negative numbers? What purpose do they solve? Why were the complex numbers invented? To solve what need? What are the practical applications? How it helps solve real world problems? When children understand the why, they don't just solve the problems, they start seeing the world differently. Today's math often feels rigid. There's only one correct method. You must divide 125 by 5 exactly the way it's taught, or your marks get cut. But real math is creative. It's not just about using tools, it's about creating new ones. It is going beyond what exists. That is how negative numbers, complex numbers, or the concept of limit, or so many other things got invented. Yes, invented because they do not exist in nature. Can you say I have -1 phone, or I have -2 books? No, right? But they serve a specific purpose. And that's why their invention happened. So the question is, how do we move children from mechanical math to meaningful math? Let's take a look. Now, I know what some of you are thinking. How do we do all this when we've got a syllabus to finish? Now, let me tell you that pressure you feel to rush, it's not coming from the NEP. It's coming from a mindset we've inherited and not questioned. In fact, NEP 2020 tells us the exact opposite. It clearly calls for deep understanding over rote memorization, competency based learning, not content heavy coverage, conceptual clarity, and inquiry based pedagogy, reducing curricular load to make space for real learning. So, no, NEP does not ask us to rush. It invites us to slow down, to go deeper. Let's not forget, shallow coverage builds shaky foundations, but depth builds confidence, curiosity, creativity, everything our children need, especially in the AI age. Let's not forget again, NEP came in 2020. That's before Chat GPT, before the AI wave, before children started casually using tools more powerful than we ever imagined. Back then, the call to move away from rote learning made sense. But today, it's not just a call, it's a necessity. Till recently, teachers held the upper hand. We knew more than our students. But that information gap has disappeared. Today's children can get any answer from Chat GPT in seconds, but what they still need is a teacher who can guide their thinking, who can help them understand, question, explore. And that is why syllabus coverage is in the traditional sense makes less sense than ever before. The real task now, transforming our own mindset, our own pedagogy, because once we do that, helping children develop a mathematical mindset becomes effortless. Now, all right, I'm going to quickly show you this math problem. It's written on the screen, and I'm going to give you 10 seconds to solve it. And I have a little bonus for the one who gets it under 10 seconds. Ready? Yes, your time starts now. I want people to answer this. The question is written on the screen. Everyone, please read the screen. Thirty 30.5, it is not well defined. 8.5. 30.5, 30.5, 30.5. Okay. All right. Thumbs up. I could just see one person asking the right question. It depends on the data. It depends on the direction. Now I can see a lot of people writing, the data is insufficient or something like that. But I could immediately see people writing 30.5. We jump to the answer directly. We don't even ask questions, because I've asked this same problem to hundreds of adults and children, and 90% plus give me the same answer, which is 30.5 kilometers. Why? Because we've been trained to compute, not to think. So look again at the visual. Yes, some of you rightly asked the critical question, which direction did she go from her brother's place? Or the data is insufficient. Was it forward, backward, left, or right? That one piece of missing information completely changes the answer. And that's the point. The real power of math is not in getting to the answer, it's in asking the right questions. That's what our children need today. Not more formulas, not faster calculations, but better questions. And once they start thinking this way, they won't just solve math problems better, they'll solve real life problems better. Now, let me show you one more example. Read the question on the slide. I'll give you 1 minute to solve it. And just like last time, there's a special bonus for anyone who cracks it in under a minute. Your time starts now. Okay, time's running. I think time's up. 80. 80. Okay, okay. Right. I can see people writing now. It's 80. 40. Somebody wrote 40. That's okay. Okay. Now tell me honestly, teachers and educators, if you give this question to your students, what kind of looks or reactions do you think you'd get? Go ahead, type them into the chat box. I want to see emojis flowing, and I want to see the expressions on your kids' faces. Clueless. Ah, I can see the emojis also. Okay, I knew it. That's exactly what I've seen too. Right, a sad face. But let me ask you something. Is it really that difficult? Honestly, no. What makes it look difficult isn't the math, it's the habits we've unknowingly built over time. Fear of long texts, belief that every problem must follow, a formula, a tendency to give up if the path isn't obvious. Not because teachers meant to do this, but because the system made speed, memorization, and right answers the focus. But now let me show you the real math way to solve this without a formula, without panic, just pure thinking. If you have the strips with you, let this strip represent the one. Okay? Half of it was given at the first temple. So I just do the half of it and I give it at the first temple, right? This is what is left with me. This is what is left with me. Another half is given at the second temple. So half of it is given at the second temple. This is what is left with me, or so to say, the lady. Again, half of it was given at the third temple, and this is what is left with the lady. The last one, half of it is again given at the fourth temple, and this is left with the lady, and this is actually five. This is five. These are five flowers. Now, if this is five, then how much is the whole? If this is five, then how much is the whole? So there'll be 16 such fives, and 16 fives are 80. So you see what just happened? This question did not need formulas. It didn't need any kind of algebra also. It just needed clear thinking. And that's exactly what we are not training children to do. We're so busy rushing to complete the syllabus that we forget to build the mind that can think through such questions. We are preparing children to answer fast, but we should be preparing them to pause and think. That's the kind of math that matters in real life. That's the kind of math that builds future ready learners. And honestly, teaching this kind of math isn't about doing something extra. It's about doing the same topics just a little differently. By slowing down, by asking better questions, by creating a space for inquiry and thinking. Because when we do that, something magical happens. Students stop fearing math. They start trusting their own thinking. Now let me pause and ask you, what is a math mindset? Is it about being fast? Is it about remembering formulas? Or is it something deeper? Take 10 seconds. Think about it and drop your one-line response in the chat box. What is a math mindset? Think logical, solving skill, formula, visualizing, creativity and imagination, being problem solvers, think logical, enjoying math, explore problem solving, visualization. Okay, for me, a math mindset is not about how many questions you solve, it's about how you think when you approach a problem. It's the belief that mistakes are part of learning. Struggle means your brain is growing. There's no shame in asking a why. And most importantly, a strong math mindset is what prepares our children for an AI powered future where answers are cheap, but thinking is priceless. Let's now look at a few short scenarios, real classroom moments, not testing your math, but your mindset as an educator. Now, these questions aren't about, right or wrong. They're an invitation to pause, to reflect. Okay. I've been a teacher long enough to know we all carry habits, some that help, some that hinder. So let's treat this like a mirror, not a microscope. Even a small shift in how we respond in classrooms can ripple into a big difference for our students in their lives. Let's see what these moments reveal about what we believe and what we might be ready to change. Let me just create the poll for you. Let me launch the poll for you. So I think it's been launched. Yes, it is. Let's take the first scenario. I've launched the poll. A student takes longer but asks, why is area equal to length into breadth? How do you respond? There are three options which are given. Tell them to memorize the formula first, show them using tiles or drawings. Say we learn that later, just one, use it for now. Okay, I can see a lot of people clicking on the second option, which is show them using tiles or drawing. I can also see some of the people clicking on the first and third options. But yes, the majority of the people are clicking on the second option, which is show them using tiles or drawings. So when a child asks why, that moment is gold. It's not a distraction, it's a doorway to nurturing math mindset because that's what the child is displaying. Questioning, thinking critically, wanting to understand, not just remember. If we dismiss that curiosity, we don't just shut down one question, we shut down the culture of inquiry in the whole classroom. So, yes, when they ask why area is length into breadth, don't rush to the formula. Lay the tiles, draw the grade, show them, and let them arrive at it. So 93% of the people said that they show them using tiles or drawings, and that's beautiful. I have the next question for you. Let me just go back to the... Yes. So I'm going to launch the poll again. A child says, ma'am, I got the right answer, but my method is different. What's your immediate instinct? Oh, maximum people, and in fact, all of them. Okay, no, I can still see some percentage saying check if it matches the textbook method. And some are also saying tell them to follow the same steps as the class. But yes, majority of 97% of 96% of the people are saying that ask them to explain their approach. There are 3% and 3% respectively who said check if it matches the textbook methods. Tell them to follow the same steps as the class. So uniformity is easy to control, but it can quietly kill mathematical thinking. So if a child says, my method is different, our first instinct should not be to correct, but to listen. Because when we only reward one method, we are not teaching math, we are teaching them obedience. Follow this, follow that, and so on and so forth. But when we allow space for different approaches, we build thinkers, not just followers. So before you say, follow the class steps, or, explain the same steps, or maybe check if it matches the textbook method, pause and say, tell me how you thought about it. That's where the real learning will begin. Okay, so I'm going to end this poll and I'll launch another one for you. Where the question is this. Yes, this is a poll again. You ask a child, what is 1/3 of half? And they quickly reply 1/6. What do you do next? Let's be true to ourselves. Let's not click at the most ideal answers. I don't want to look for the ideal answers. I want to see how are you people responding. And that's absolutely correct, because I've been through the same situation and I know it very well. So move on. They know the answer. Currently it's like 9%, 9 to 10% are saying move on. They know the answer. 62% are saying, 61% are saying that ask them to explain using a diagram. And 30% approximately are saying give them more similar sums to practice. Okay, I'm going to end the poll for you. And see, correct answers are not proof of understanding. Just because the child says 1/3 or one half is 1/6, that does not mean they understand it. The real question is, can they show it? Can they explain it? Can they apply it in a new situation? Because in math, what sticks isn't what we memorize. It's what we can visualize and make sense of. I'm going to end this poll again and back to the next question. So these are all questions which will just reflect your mindset as an educator. The next question for you is this. Let me just, yes. When a student asks, why do we need to learn trigonometry? What is your most likely response? Okay. I can see maximum people, great question. They're clicking on the third option, which is great question. Let's explore where this shows up in real life. And again, I can see it's people clicking on it's useful in engineering and architecture. There are there are 3% who are still saying it'll come in exams and just focus for now. Okay. So when a student is asking, why do we even need trigonometry? He or she is not questioning your authority, mind you. They're just curious. Now, the real question is, do I honor that curiosity? Even if I don't have the perfect answer in that particular moment, or do I shut it down with, it'll come in the exams, you just learn it? We often say we want children to be curious, but curiosity can't survive in classrooms where why is treated like a distraction. We need to reflect and see how often do I use because it's in the syllabus as a full stop instead of a starting point. Once we observe that in ourselves, that's the first step towards change. Okay, so I'll end the poll again and back to the next question. Let me launch the question for you. Just a moment. I think some of, let me just check. Yes, I got it. So the question is, during a test, a student solves a problem using a non-standard method and gets the correct answer. What do you do in that case? So you have the poll on your desktops. What do you do then? Let's be true to ourselves, please. Okay, I can see maximum people clicking on, ask them to explain their thinking before assigning marks. And again, a great percentage saying give full marks and praise the creativity. Some of the educators are also saying mark it wrong, they didn't follow the taught method. So, okay, I think people have voted now, and 4% are saying mark it wrong, they didn't follow the taught method. And 30% are saying give full marks and praise the creativity, and 66% are saying ask them to explain their thinking before assigning marks. I'm sure that our first gut is to check if he's applied the formula we taught or not. It has happened with me as well. But now I pause, take time, and see how student has approached it. And many a times you are amazed at child's intuitive understanding of the problem. It opens up your mind. So you need to ask yourself, do I reward only what's familiar to me? Or do I make space for how children think, even if it's different? Because real math is not about replicating steps, it's about reasoning through problems and sometimes finding new paths to the same destination. Do we want compliance or do we want competence? Okay, ending the poll. And another question for you. Launching the poll now for you. You're behind on syllabus. You reach a complex topic like quadratic equations. How do you plan the next few classes? This is very interesting. So this is a difficult one considering that till now majorly the focus has been on course completion. But where does that focus, come from when NEP states otherwise? So I can see uh, maximum people voting for focus on understanding, even if it means reducing exercise quantity. Some of you have still said speed up, cover key methods, and give worksheets. And less percentage, only 4% people have opted for skip explorations and stick to exam patterns for now. This pressure comes from an old mindset, one that says completion is more important than comprehension. But what's the point of covering every topic if children don't understand them? This is where we need to lead the change. First in our own minds, then in the staff room, and eventually with parents and school leaders. Because once you're convinced, once you've seen what deep understanding does, you'll never teach the same way again. And I have the last question for you, final one from my side, and ending the poll and starting the new one. Yes. A student says, Sir, I learned this differently from a YouTube video. What is your response? I can see, some people truly clicking on stop wasting time watching random videos. But yes, maximum people, I mean, it's 97% who are stating, let's compare the two methods and see if both works. and only 1% are saying, forget that, follow what's in your book. Now, when a child mentions YouTube, does it make you full of anger or scared? Do you feel challenged? Or do you see it as an opportunity to deepen students' understanding? Today, I hope we all understand that we can not stop students from using all these tools, whatever we do. The time is gone when information was teachers' power. But now, no more. We need to accept it. And unless we become comfortable with this fact, we'll keep on feeling challenged. So, before nurturing students' mindset, we need to nurture our own mindset, which will come with the understanding that today the superpower of a teacher is empathy, it is patience, connection, curiosity, and not information. We need to shift our approach from instructions to interactions, and then everything else will take care of itself. Let me just go back to the yes. So the future of math won't begin with the syllabus. It begins with us. With every pause, every question, every moment where we choose understanding over speed. That's the moment a math mindset is born. And once it is, that child is never the same again. So, if anything from today's session resonated with you, I'd love to stay connected. I regularly share resources, run workshops, and design programs to help teachers, students, and parents fall in love with math, in a way that's truly built for the AI age. Feel free to reach out, connect on LinkedIn, follow on Instagram, or just say a hello. So, this is it from my side, and I'm open for any kind of questions. Thank you so much.
Thank you so much, Garima ma'am,
Should
for
I stop
such
sharing?
insightful session. And participants, chat box is open for your questions. If you are having any specific query, any question you want to ask, you can put it in the chat box.
Thank you so much, everyone. I can see Tanka Mishra asking, sometimes students come ahead with a very interesting solution from the internet, which we never had thought of. And we also get to learn. Learning is never. That's true. That's true. That's what we need to be, open with whatever, whatever information, whatever inputs are from the kids. In fact, that's a beautiful way to manage the classroom. Thank you so much. I can't how to teach percentage to the students. It's kind of challenging for the students. That's right, Shanu. Percentage. Okay, first of all, percentage is it comes from the word percent. That means per 100. Cent is 100. So per 100. So I think the best way to do it is again through the paper strips. So take a block, divide it into 100 parts, and then try to figure out. So if it is like, how much is, okay, I'll give you a small instance. Since it is over 100 per 100, the smallest instance which I can just think of right now is, so if it's, say, suppose, how much is 60 on 80? Okay, I'm just giving you an instance how I could get an answer from one of my students, from, in fact, my own child only, from my own son, that what is the what percent is 60 by 80. So 60 by 80 is like 60 on 80, and you need 20 more because you needed over 100. So it's like 20 is 1/4 of 80. So 1/4 of 60 would be 15. So 60 plus 15 is 75. So just, okay, you have to let the kids be first of all, and then they'll come up on their own. You just need to explain the basic logic behind what is percentage. It's per 100. Okay. And in fact, if I see the percentage, the definition itself is wrong, because it has to be over over a quantity. Percentage is over a quantity. But what we are doing is, the basic definition in the books is over the number itself. It's over the number itself. So I can't tell you exactly how to go about it. That's what I've told you. You just have to let the kids be, and give them paper strips, or square with 100 marks on it. So 10 vertically and 10 horizontally will give you a grid of 100. And I think from there, they would be able to learn about percentages.
Garima ma'am, one question we have from one of our educator: how to deal with large syllabus in short time? How to
Okay,
deal with
so
large
how to
syllabus in
deal
short
with
time? Yeah,
large syllabus
in
in a
short time.
I think we just need to what we do. I've been a teacher through all these years. What we usually do is we focus more on the questions. I would rather say, if you have, say, suppose if you want to devote say suppose 10 classes to fractions, I would suggest give 3 initial classes to the concept. What we do is we rush through the concept and we focus more on the questions. Do it the other way around. Focus on the concept. Tell them what is one fourth. Show them what is one fourth. Now, if you just telling you, if you just show it through the strips, okay, the method which I just showed you, demonstrated you, if you just show it through the strips, you see this is one third, right? This is one third, and this is one fourth. Can't you just, this is one third and this is one fourth, can't you just see it? Them can't the kids be able to, won't the kids be able to see it themselves, that one third is bigger than one fourth? So once the concept, I mean, once you show it, once they're able to visualize it, all the concept would be very clear to them. So focus on the concept itself, then come to the questions. And also one more thing I would suggest, that you can also give the questions to themselves, let them solve it on their own, let them do it on their own first, and then you can maybe discuss it in the next class, the upcoming sessions, but focus more on the concept. That is what my suggestion is.
One more question, ma'am. We have how to build mathematical thinking
I
among
can't hear
students.
you, I'm so sorry,
Uh,
there's a lot of disturbance.
can you hear me?
Yes.
Yeah. So, ma'am, the question is how to build mathematical thinking among students.
So I think usually what is happening in the classrooms is that we are lecturers, we are teachers, and we are there to teach. We have to first of all change our designation from a teacher to a facilitator. So give them open-ended question, let them discuss about it. And I'm telling you, this is with my own experience of over 15 years, more than 16 years now, they will definitely come up with a solution. And when I say that mathematics is a language, every concept that there is, it is derived from the English word itself. If I'm talking about what are prime numbers, that comes from the English word prime itself. Think about related to prime minister. It is the first amongst the equals. It is the the highest category. So prime numbers are the same. So I think you just have to give them the question, let them explore on their own, and then add to their knowledge. That is what I would suggest, that's how the mathematical mindset can be cultivated in kids, because otherwise it is just the teaching which is happening, and that is what we need to restrain ourselves from.
Thank you so much, ma'am. So I believe these were the only questions that we have, and we are getting a lot of positive feedback for your session.
Thank you
Really,
so
the
much,
session was
everyone.
very much insightful.
Thank you. Thank you so much.
So thank you, Garima ma'am, for the enlightening and powerful session. You have reminded us that nurturing a mathematical mindset is not about memorizing solutions. It's about thinking critically, exploring creatively, and building confidence in problem solving. Up next, we'll continue our summit journey with another engaging session from 4 to 5 p.m. that will further expand our understanding of mathematics teaching and learning. But for now, let's take a break and join us back at 4 p.m. for the next session.
Thank you